Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
So how do we solve an equation, right? Two equations actually with two unknowns. This is a physics problem, velocity of a hammer, velocity of a rock, and I've got my TI-nspire calculator, and I'm going to do this graphically. So I'm going to click here on the graph, right? And I'm going to click on the tab button. And as a note, I want to set it up right here so it says REL. Now let me just make a note. It's important. Oftentimes what's going to happen into the graph entry mode is you're going to be under function mode, right? F of x. But I want to switch it over. Math teachers love the f of x, but us physicists, we're going to be a little bit more interested in the REL, or relationship. So then I can actually type the equation. So you can see my equations on the piece of paper, so I'm going to simply type it in. 2.64 equals, the equals button's right here, right? Equals 0.55, I'll say VH is x, right? Plus 0.21 y. And as you are probably well aware, I now have just made a graph. But I'll now do the second equation, right? So this is actually momentum equation. This is a kinetic energy equation. I'm going to then go back to the tab button, and I have the second relationship, 6.36 equals 0.275 x squared. See how that's typing in there. Plus 0.105 y squared. And I'm going to now say enter. And notice, you might notice, we've got two different, we've got a circle, the second number is a sort of oval, I should say, and then we've got the, notice that there's a couple of intersection points, and I'm gonna zoom that in a little bit. So I'm gonna go to menu, and I'm gonna go down to zoom number 4 right here, and I'm gonna zoom in, right, so that's number 3, I'll just type the 3, and I'm gonna move my cursor, I wanna zoom in about right here. Okay, actually I'm going to probably zoom out right here now too. So that's what I want to zoom from. And I'll go menu, zoom, now out, right there. Perfect. So I wanted to move it over just a skosh. Now what I want to do is I want to find what those intersections are. So if you've got notice here now, think about this. This is an actual physics problem. So there's going to be two sets of answers, two x's and two y's, where these are equivalent statements. Now, in terms of physics, if my physics students pay attention, you're going to have to think this through and find out which one makes the most sense. Now I'm going to find the intersection. Again, I'm going to go to the menu button. I'm going to go to analyze the graph. As a note, you can just type the 6 button, and intersection is 4, or 64, I like to think of it. So I tap here. What I'm trying to do is to outline where the intersection might be. So I click here, and it gives me the intersections. I'm going to find the other one. I'll just do menu 6, 4. I'm going to find this point too. Boom. Now this is where you'll have to think some things through. Hold on, let me move that. It's found the intersection, and the intersection, let's move that up. So we've got two intersections. We've got 2.1, comma 6, comma 7, let's say, and 4.8, kind of negative 0.02. Now, at this point, my physics students, what you'll have to do is think through the physics of the problem and which set makes sense, because only one set will make any sense from a physics perspective. But if you have two equations and two unknowns, oftentimes, in this case, because of the nature of this graph, there are two different solutions because of the x squared and the y squared components. So not too hard. A simple thing, graphically define two equations and two unknowns. Houston, it's not so hard.